Good day, students. By the way, I am Leoniel Ramos, a BSed Mathematics 3 student, and I am here to talk and discuss about the related to alternating series test. By the way, what is alternating series test? Alternating series test is called alternating series test because it is a test that alternates in sign. Like for this example, negative 1, positive 1 half, negative 1 third, positive 1 fourth, and so on. So, alternating series test follows two different formulas. The only difference between the two is the sign. The plus 1 indicates if it is positive or negative. So, in order to solve a alternating series and to identify if it is converges or diverges, we need to follow a certain steps. First step is to find if it diverges or converges. Let me set an example, this one. Let's know if it is converges or diverges. And approaching infinity, our a a sub n is equals to 1 over n. So let's type 1 over n. 1 over n. And let's equate it into 0. Why 0? Because if we replace the infinity here in n, it will look like this. Limit of n approaching to infinity is equals to 1 over infinity or equals to, yes, 0. So if the equation is equal to 0, that means it converges. So it passes the divergence test. On the other hand, if it is not equal to 0, if it is negative or greater than 0, it means that it didn't pass the divergence test and it belongs to diverges. The second step is to check if it's a decreasing sequence test. To identify if it is decreasing, we need to consider this. An plus 1 must be less than or equal to a sub n. So in this problem, what is our a sub n? Our a sub n is 1 over n. So let's write it here. A sub n is 1 over n. Therefore, our a sub n plus 1 is 1 over n plus 1. So in the rule of fraction, if the denominator is increasing, the value of our fraction is decreasing. Therefore, in this phenomena, or in this inequality, it is understandable and it is reasonable that 1 over n plus 1 is always less than 1 over n. Therefore, it passes the divergence test and it is in a decreasing sequence test. Therefore, we can conclude that this problem here this alternating series test here converges. Converges. Okay. So, without further ado, let's proceed to another problem. So here is our second problem, where a sub n is equals to 5n plus 2 over 3n plus 3. So, like the previous one, we need to find the divergence test and we need to check if it is in a decreasing sequence test in order to identify if it is in converges or diverges. So, first of all, let's find if it is converges. Since our a sub n is in this form, we need to use the derivatives or the rule of derivatives, which is and since our limit where n approaches to infinity is not equal to 0, therefore we can conclude that this problem here diverges. And since it from the first step we failed to assume and presume that this problem converges, therefore we cannot check if it is in decreasing sequence test. Therefore, we will conclude that this problem right here actually diverges. So let's proceed to another question. But first, allow me to erase this one. This is our new problem, where our A, where we didn't know our A sub n. So first and foremost, we need to arrange in such a way that we will find or we can find the value of our A sub n. Copy this one, infinity, and equals to 1. So let's separate this one from this one. Therefore, it will become negative 1 to the power of n times 1 over n factorial. From this new series, we can identify where is the a sub n, and it is right there, right here. Our a sub n is equals to 1 over n factorial. So let's identify if it passes the divergence test. Divergence test. Limit of n approaches infinity of our a sub n, which is 1 over n factorial, must be equal to 0. So is it really equal to 0? Let's find out. 1 over infinity factorial is understandable as 1 over infinity. So equals to 1 over infinity. Therefore, therefore, it equals to 0 since 1 over infinity is always equal to 0. Therefore, the problem of our A equals to 0. So it passes the divergence test. So let's proceed to the second step, which is checking if it's a decreasing sequence test. So we all know that our A sub n is equals to 1 over n factorial. Therefore, our A sub n plus 1 is 1 over n plus 1 factorial. From this one, we can identify that the denominator here is greater than the denominator here. Therefore, our A n plus 1 is greater than our A sub n. So, our A n plus 1 is greater than or to A sub n. Therefore, it is in a decreasing sequence test. So, we can prove that this problem right here is our A sub n is equals to negative 1 to the power of n over n factorial actually converges. So that's it for this video, students. Thank you for watching.